Hey everyone, how's it going? In this video, we're going to be solving this LeetCode problem, next permutation. So let's see what's the problem given to us is. It said a permutation of an array of integers is an arrangement of its members into a sequence or linear order. For example, array of 1, 2, 3, the following are considered permutations of array 1, 2, 3, 1, 3, 2, 3, 1, 2 and 2, 3, 1. So the next permutation of an array of integers is the next lexicographically greater permutation of its integer. More formally, if all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows in it in the sorted container. If such arrangement is not possible, the array must be rearranged as the lowest possible order, that is sorted in ascending order. So essentially what the problem says is that we are given some sort of a input and we have to return the output of the next permutation that can happen for that input. So one way to solve this problem is by using the previous approach of the previous problem, that is permutations, which I made a video about. But this problem can also be solved using something like a optimal solution. There is obviously an optimal solution. As you can see, I have already written it down, already coded it down, because doing the coding is boring and it wastes a lot of time. So I have already coded out the solution, optimal solution. I will just go through the algorithm for this video. Okay, so what is the optimal algorithm for this solution? Let's first write the algorithm. Okay, let's write the algorithm first. Okay, let's suppose we are given a number something like 1, 3, 1, 3, 4, 1, 3, 4. No. Let's suppose we are given a number as 1, 3, 5, 4 and 2. Pause the video and think what would be the next permutation for this number. What can be the next permutation for this number? So the next permutation for this number would be something like 1, 4, 2, 3 and 5. So how we are getting this thing? Okay, let's see. So we have the number as 1, 3, 5, 4 and 2. Okay, so if you look at the dictionary order, the number is first increasing and then again it is decreasing. Okay, so we have to find out this breakpoint, the breakpoint where the number gets decreasing, the number is decreasing. We have to find this breakpoint, and in every lexicographical order, this thing will happen. The number will always break at some point, the number will always decrease at some point. Okay, so essentially what we are doing is we are finding this breakpoint. We have to find this breakpoint, and then after finding this breakpoint, what we will do is, let me erase this first. One, 3. Okay, so after finding this breakpoint, what we will do is we will now we have a number. Okay, so we have already found out the breakpoint. Okay, we have already found out the breakpoint, and the number before that breakpoint is obviously 3. So we have something as 3 as our pivot. We can call 3 as our pivot. Okay, 3 is our pivot. Okay, so now what we need to do is, now think about what would be the number which can be greater than 13. Obviously the numbers can be which is greater than 13 is 1, 4. Okay, 14. So what we will do is we will check for the element which is closest to our pivot. So So in this case 4 is closest to 3. Okay, obviously we could have had something like 5 with 5. Okay, but is 15 closest to 13? No, 14 is closest to 13. So that is why we are choosing 4 as our closest to pivot. Okay, so what we will now do is swap 3 with 4. Okay, so now our number becomes 1 4 5 3 2. Okay, so we already have a number. We have a number which is greater than 13452. Okay, which is greater than 13542. But is it the next permutation? No, it cannot be the next permutation, because for our next permutation we need to have something. We need to have the numbers which are sorted. Okay, so what I am essentially saying is that we have this 532. Okay, if we sort this 532, what we will get is 1 4 2 3 5. Okay, now this number is our next permutation. Let's see why we are sorting this part. Okay, suppose you are given something as 321. Okay, no, sorry, not 321. Let's suppose we are given something as 123. Okay, 123. Are there any numbers which are lesser than 123? Every number we will get will always be greater than 123. So why 123 is the smallest? Because 123 is already sorted in ascending order. That is why it is the smallest number which is possible. So that is why we are sorting this part. Okay, that is why we are sorting this part. If we sort this part, then only we would get something which is closest to our original number. Okay, I hope you get the intuition behind the algorithm. And let's now see the coding solution. Okay, now let's see the coding solution. So this is a base case check. In this part, what we are doing is just checking if our nums array is less than if the nums array contains only one value, then we would just return. Now what we are checking is we are having one I. What we will do is 1 3 5 4 2. Okay, so what we will be essentially doing is traversing the array from the back. Okay, and find any possible index where I plus 1 is greater than I plus 1. So in this case I is greater than this part I plus 1. Okay, so we are finding that, and then what we will do is we will swap the closest possible number which is closest to the pivot element. That is, we will swap 3 with 4. Here we are swapping 3 with 4, and then after swapping, what we will do is just reverse the last part of the suffix of the array. Okay, so what we will do is reverse the suffix of the array, and that is how we will get something like the next permutation. Let's run the code. I have already run the code like several times. I was getting some sort of error every time, but now it runs. Let's run the code. Okay, cannot find symbol A. Oh, sorry, this would be nums. Okay, let's run the code. Okay, it runs. Let's submit. Yes, it's submitted. Yes, the code submits, and as you can see, the runtime is 0 ms. So I hope you get the solution. This was a pretty great question. This was like a great question to do, and this question actually comes in interviews. Okay, so practice this question a lot, and try to understand the intuition behind the algorithm. The algorithm is kind of easy. One thing I could say to you is, if you don't get the intuition behind the algorithm, do one thing is write all the possible permutations for the number I had shown. Okay, write all the possible permutations for 1 2 3 4 5. Okay, write all the possible permutations and check the pattern behind all the numbers, how the permutations are happening. Check the pattern. You would see there is a dictionary pattern that I said is happening in that part. Okay, in every possible permutation. Okay, and then run your test cases with my solution. Okay, with my algorithm intuition, and you will get the solution. So this is for it today, and I will see you in the next video. So bye.